Ever wondered how a spaceship could travel faster than light? Meet the quantum inertia nullifier and the Higgs distortion drive. These two concepts are not just fancy words pulled out of a sci-fi novel, but rather they are theoretical propulsion systems based on the principles of advanced quantum mechanics. Quantum mechanics, for those of you who missed that day in physics class, is the branch of physics dealing with the smallest particles in the universe. It's the foundation for both the QIN and HDD. Now let's take a quick detour to the concept of inertia. In layman's terms, inertia is the resistance of an object to any change in its velocity. This includes changes to the speed and direction of motion. Inertia is directly related to mass. The greater the mass of an object, the greater its inertia. Now imagine if we could manipulate this inertia. This is where our friends QN and HDD come into play. The Higgs distortion drive works by manipulating the Higgs field, the field responsible for particles acquiring mass. By tinkering with this field, the HDD can effectively reduce the spacecraft's mass, and in turn, its inertia. It's like going on a cosmic diet. The quantum inertia nullifier, on the other hand, takes this concept a little further. It aims to nullify inertia altogether, reducing the mass to near zero. It's like the spaceship becomes a feather, capable of zipping around the universe with ease. Both these concepts, QIN and HDD, aim to achieve high-speed space travel. By reducing or nullifying inertia, these drives facilitate rapid acceleration and deceleration, which is crucial for zipping around the cosmos. It's like having your own personal hyperdrive, but without all the pesky side effects. Imagine a spaceship with almost zero mass, zipping across the universe at light speed. That's the magic of QIN and HDD. Now, isn't that a mind-bending thought? Join us in the next scene as we delve deeper into the alignment of the QIN and HDD concepts. So, how does the quantum inertia nullifier align with the Higgs distortion drive? Let's dive in. First, let's start with the basics. Both the QIN and HDD are rooted in the complex world of quantum mechanics. The HDD manipulates the Higgs field, a key player in particles gaining mass, which can be seen as a quantum mechanical process. Therefore, the quantum in QIN is perfectly in sync with the HDD's operating principles. Next, let's talk about inertia and mass manipulation. The greater an object's mass, the higher its inertia. The HDD concept plays around with the Higgs field to effectively shrink the spacecraft's mass, and consequently, its inertia. The aim of QIN to nullify inertia aligns beautifully with this mass manipulation aspect. By trimming the mass to nearly zero, inertia would also be nullified, making the name quantum inertia nullifier a fitting moniker for the HDD. Finally, we come to speed and maneuverability. The HDD's ultimate goal is to enable light-speed travel by reducing the spacecraft's mass. The QIN, by nullifying inertia, would inherently allow rapid acceleration and deceleration, which is vital for such travel. This makes QIN an apt name for a drive designed to achieve these effects. In essence, QIN is like HDD 2.0, taking space travel to the next level. Now, let's explore the conceptual synergy between these two fascinating concepts and how they could fit into a sci-fi narrative. Imagine the Higgs distortion drive, a technology that manipulates the Higgs field to reduce a spacecraft's mass for high-speed travel. Then envision its evolution into the quantum inertia nullifier, a more refined technology that nullifies inertia for enhanced control and efficiency. This progression from HDD to QIN could be a compelling plot element in a science fiction story, showcasing the relentless march of technological advancement. But it's not just about speed. The leap from HDD to QIN suggests a broader functionality, a focus on overall spacecraft maneuverability and control. It's like upgrading from a fast car to a supercar with pinpoint handling. Both are speedy, but one gives you more control. And in the vast expanse of space, control is just as important as speed. A deeper understanding of quantum mechanics and the Higgs field could be woven into the narrative as well. After all, these are the fundamental principles that make HDD and QN possible. They could be portrayed as the keys to unlocking new frontiers, the secret sauce in the recipe for interstellar travel. So, next time you read a sci-fi novel or watch a space movie, pay attention to these concepts. Who knows? the quantum inertia nullifier might just be the star of the show.